Okay, so the question that arises from people is, what's the difference between when I'm working with here? Let me get a pointer going. What's the difference between with a normal probability calculation between a greater than or equal to or just a greater than? Well, we can do a lot of the algebra with it, but it might be easier just to look at the applet and do that. So what I did on a related video that I just recorded, I said, okay, what's the probability of getting a value, a z-score, greater than 2.13? Now is this answer, and I said, well, we could ignore the equal to. Well, why is what comes up. So so the question I want to answer is, what's the probability of it? I mean, in a binomial distribution, we can find that binomial PDF, find the exact probability of finding a single value, because it's a discrete variable, and just discrete random variable, whereas the normal curve is a continuous random variable. So is it, instead of a fixed width, is it, that width can get very narrow. So let's look at this. So what if I want to do, I'm going to change this to between, and I want to go 2.13, and let's put 1,000. And that should be the same answer as we just got. So now what I'm going to do is I'm going to shrink up, I'm going to change that area. I'm going to get closer and closer to 2.13. So let's say 2.2. Okay, see how that area is narrower and see how that probability is smaller? What if I get to 2.15? Now we're within 1/100th of it. So see how that area, that rectangle, is getting skinnier and skinnier, and notice how that probability is getting smaller and smaller. Well, what if I go to 2.135? Notice how that area is getting smaller and smaller and smaller, and that picture is getting smaller and smaller, that rectangle. So what if I go 2.31? What does it do for me? So I've got a rectangle about 1/1000th wide times however high that probability area is, and it's telling me that area is 0 because I have almost no area associated with exactly 2.13. So that's why when they ask us, when we're asked to find the probability of in a normal distribution, any normal distribution, of greater than or equal to versus greater than, it's the same number because the probability of getting exactly the equal to part is going to be 0. Okay, so hopefully that helps defend why we can just ignore the equal to in these normal distributions. Hope that helps.